This lesson is going to be on exponents, exponent rules in particular. So we're going to look at 6 different rules for exponents, and I'm going to try to sort of semi-derive why these properties actually work to help you remember them. So the first one we're going to look at is multiplying powers with like bases. So if I had something like x cubed times x squared, what does this mean? So we can write out x cubed and x squared, and what they mean, right? X cubed is x times x times x. X squared is x times x. So when we put these together, what happens? We just get x to the 5th. And so we've now sort of given some motivation for our property. Rather than having to do that every time, I can simply just add the exponents together. So if I am multiplying like bases, I can add the exponents together, and that's what that says, right? X to the m times x to the n equals x to the m plus n. And hopefully now it's not one that you have to memorize, but it'll be one that you can sort of say, sure, that makes sense on why we have that. Dividing powers of like bases. So if I had x to the 5th divided by x squared, you could probably derive this on your own. We may have done this in class. So x to the 5th equals, and we have 5 x's, and x squared, we have 2 of the x's. And when we put these over each other, what's going to happen? Good. 2 of those x's cancel out, and I'm just going to be left with x times x, or x cubed. And so that's my second rule. When I'm dividing like bases, x to the m divided by x to the n, it's going to be the difference between the two, x to the m minus n. So the third rule. So case 1, this is the zero exponent rule. If I have a cubed over a cubed, how can I evaluate that? I can apply that rule, right? The rule I just learned. I can just subtract the 2. So this is going to be a to the 3 minus 3, which is a to the 0. Well, what does that mean? Well, what else do we know about a to the 3rd over a to the 3rd? Right. Just from, we can cancel out both of these, right? Anything divided by itself is 1. So, therefore, a to the 0 equals 1. This is just some motivation for why this works. And this is our third rule, a to the 0 equals 1. This is really anything to the 0 equals 1, except for 0. And we're not going to talk about that. So raising a power to a power. So if I had x squared times x cubed, let's see if we can kind of semi-derive this. So what does x squared cubed mean? Well, it means I'm going to have x squared times x squared times x squared. And from the first property that we learned, what are we going to do with those exponents? Good, we're going to just add them up, x to the 6th. And this is our fourth rule, exponent rule. X to the m raised to the n is x to the m times n. Raising a product to a power. So if I had 3x quantity squared, so this is 3x quantity squared, what does this mean? So 3x squared means 3x times 3x, which is 3 times 3 is 9, x times x is x squared. So this is 9x squared. So really all I need to do is raise each of those to the exponent. So xy to the m is x to the m times y to the m. So really what we did here was 3 squared times x squared. And when you have just a numerical quantity, 3 squared, it's usually best to evaluate that and get 9x squared. Now we generally will just do this step in our head. This will be sort of an optional step. Most don't show this unless this gets really complicated, but you can square 3 in your head and just go straight from here to here. So often we'll use these properties without thinking about it, and you want to make them somewhat second nature. So raising a quotient to a power. So if I have x divided by y cubed, again, what does this mean? When I'm cubing something, I'm just multiplying it by itself that many times, 3 times. So x over y times x over y times x over y, which is just x cubed over y cubed. So again, our rule number 6 is if we have x divided by y to the m, I can just apply that exponent to the top and to the bottom, numerator and denominator of the fraction. So here's a summary of these rules. I recommend printing these out and just sort of having them by your side when you're working through these problems. And eventually you will end up remembering these. So let's combine these properties. And this is where it gets a little tricky. Ooh, I misspelled combining, didn't I? Combing the properties. I guess we are going to be combing these properties. So 3x squared times 5x cubed. I think this is one you can probably do on your own. Go ahead and pause the video here and see if you can just work ahead of me. Go ahead and pause it. All right, welcome back. So if I'm going to be multiplying these, I will generally work with the coefficients, the numerical part first. So 3 times the 5 is 15. Now technically what I'm doing is I'm just rearranging these terms. So technically I'm doing 3 times 5 and then x squared times x cubed. So what is 3 times 5? Is 15. X squared times x cubed is x to the 5th. You don't have to do that step that I put in there, but you certainly may. Okay, how about the second part? Maybe I should have labeled this one A and this one B, just for labeling purposes later on. So simplify 4x quantity squared times 4x quantity to the 5th. Okay, so this one you may have done a longer way. My intention here, again, from our property x to the m times x to the n, what do? We keep the base and add the exponents. Oh, so this is 4x in parentheses raised to the 7th. This one's a highly missed problem. You could have squared out the 4x and then raised 4x to the 5th, but that was not my intention there. And so we can just leave it like that. Now when this is technically 4 to the 7th times x to the 7th. And so I could get the calculator out and say 4 raised to the 7th, get a value, 16,384. X to the 7th. Okay. When this number here, this coefficient, gets above maybe 1,000, I generally would just leave it in this form right here. If you're doing homework in my math lab, it'll tell you how to leave the form. And if you put the wrong one in, I can certainly override that if it's warranted. Okay, so try these two. All right, welcome back. So again, these properties in isolation aren't too bad, but when you are trying to combine them, they can get a little tricky. So again, all we're doing here, and this is an optional step that most will not show, I am cubing everything in the parens. So y squared cubed. And so 3 cubed is what? 27. X cubed. Now y squared cubed, remember what I do there? Good, I multiply. 2 times 3 is 6, so this is y to the 6th. Again, this is sort of an optional step. Okay, how about the B part? So there's A part and B part. So this can get a little tricky. So before I can combine these two, I have to apply this exponent. Okay? Because think about order of operations. What comes first, multiplication or exponentiation? Good, the exponentiation does. So I'm just going to rewrite this first part, x squared y cubed. And then let's apply this square to both of these. So this is x cubed squared, which is x to the 6th. Y the 4th squared is y to the 8th. Really be careful on those. Now we can apply these. Now if you need to rewrite these side by side, you can. X squared, x to the 6th, sorry about that. Y cubed, y to the 8th. Certainly an optional step. I'll put optional there. Now we can apply it and get x to the 8th, y to the 11th. So you could have gone right from here down to here, but I would have expected to have seen this step. Don't try to do this step in your head. You'll miss it. Example 8. Pause the video here, see if you can do these. All right, welcome back. Okay, so these are actually a little more challenging. They're actually easy to do, but they trip people up all the time. So really be careful on these. So what did you do on this first one? What many students will do, call this AB, they'll try to cube out this x minus 3, and they'll try to square out the x minus 3. Now, otherwise you really wouldn't know what to do, but the intent of these is that you keep it sort of an exponent form. So again, this is the property. This is kind of like my big X to the m times big X to the n. These are exactly the same, so I can just keep the base, x minus 3, and then add the exponents to the fifth. And that's all I wanted there. Oh, I know. Hopefully you didn't do a lot of work on that one, but you'll learn. I mean, these just take some practice. Okay, simplify 5 to the 4th over 5 cubed. So this is also, it's kind of a wolf in sheep's clothing. What many students will do here is they'll cancel these 5s out. But hopefully you see you can't do that, because what does 5 to the 4th mean? It means 5 times 5 times 5 times 5. And 5 cubed means 5 times 5 times 5. Before we did this with variables, right? These 5s cancel, and I'm left with just a 5. Now using the formula, which is what my intent here was, what do you do with these exponents here? When you're dividing like bases, when I have x to the m divided by x to the n, what do? I subtract. That's all I do here. 5 raised to the 4 minus 3, which is 1, which is just a plain old 5. So again, these can get tricky. We do not cancel these out. It's really tempting to do that. I've had a hard time doing that. Don't cancel those 5s out. This is one of the cases where we actually mess up more when it's a number rather than a variable. Because if that were a variable, most students don't do that. But when we have numbers, it's really tempting to do that. So similar, let me give you another one, just on the fly. How about 7 to the 8th over 7 squared? What's that going to be? 30% will put 1 to the 6th and convert that to 1. Hopefully you see that's not the case. This is 7 to the 6th. Why is that? Because 7 to the 8th is 7 times 7 times 7 times 7. 1, 2, 3, 4, 5, 6, 7, 8. And 7 squared is over 7 times 7. These two cancel, and what am I left with? I'm left with 6 7s, which is 7 to the 6th. So hopefully these are starting to gel a little bit. They take practice. These take practice. Example 9. Pause the video here. I think you can do these two. Welcome back. All right. So first for A and B. So again, I will usually work with my number part first, the coefficients. So this is going to be 2 goes into 10 5 times. And let's say at the same time I can do with these x's, right? These are going to cancel. And then this is going to be y to the 5th over y squared. What do I do there? Good, I just subtract them. So this one didn't turn out too bad. So this is 5y cubed. Now what about part B? You've got a couple options here. I'm going to recommend that if you have an exponent here on the outside and you've got a lot of stuff in here, that we clean up all of this first in the print. So clean this up first. So what can I do here? So 4 goes into 12 3 times. And this is going to be x squared over x, so the x cancels with one of those. And then this y, it's y to the 1, right? What's that going to be? 4 minus 1 is 3. I know it can get a little messy there, but let's see, what do we have now? Parentheses still, right? I haven't applied that squared yet. That's still live. That's still ready to go. So I still have a 3, and I still have an x there. And then I canceled that y with one of those, and I've got y cubed squared. Now I can apply that squared. So 3 squared is what? 9. X squared, y to the, this is 3 times 2, which is 6. You should have gotten the same answer if you had squared everything in here. But what happens there is the numbers get big really fast. And so I find it easier, and students mostly find it easier if they'll work inside. Example 10. Go ahead and try this one. Very similar. All right, welcome back. So again, we got A and B. So did you work on the inside first? I recommend that you do. So 3 goes into 15 5 times. That x cancels with one of those, right? Because I've got 4 x's, so 4 minus 1 is 3. And then one of those y's cancels with one of those, so that's a 4. So this is negative 5 x cubed y to the 4th. And don't forget your squared. So now what are we going to get? And if you did not do this, if you didn't pause it, go ahead and see if you can do this one. All right. So this is a negative, but we're squaring it, so I know my final answer is going to be positive. So 5 squared, we have 25. X cubed squared is x to the 6. Now you're getting it. Y to the, good, 8. Okay, how about B? Pause it here, at least mentally think through what you're going to do here. We're going to assume that the denominator is not 0, the x is not equal to 0. So we'll assume that x does not equal 0, because that would give me a 0 over 0, which is messed up, and then also possibly a 0 to the 0, which we don't know how to evaluate. So what's this going to be? This is just anything with the 0 power is what? 1. So there was really no need to simplify anything in there. You certainly could. You'd end up getting x over 2 to the 0, which again is 1. Example 11. So evaluate 9x to the 0 for x equals 2. Try this one out. I know you can do it. All right, welcome back. So what'd you get here? This one's missed a lot, and I want to make sure you don't miss it. So 9 times x, which we know is now is 2, so I'm going to put a 2 in there, to the 0. Just remember your order operations. What's 2 to the 0? Careful, 2 to the 0 is 1. So this is just 9 times 1, which is 9. Okay, and that's going to do